So electrochemistry question 3. When solid barium hydroxide is added to solid ammonium chloride, a reaction takes place. Describe an experiment to show that this reaction is endothermic. Like how we can say or how we can show that this reaction is an endothermic reaction. So first what we'll do, we'll measure the starting temperature of both of these solids. Anyone want to answer? You can use your mic or a chat. So how we'll plan this experiment to show that this is an endothermic? So we'll take two containers, beakers, and we'll take equal amount of the two solids. And their solid dimension, a solid barium hydroxide and a solid ammonium chloride. So we don't have a liquid, we have a solid here. So we'll measure the initial temperature of both solids. And we leave it for some time because we want to make sure that they have the same temperature. So the first point, we will fill the beaker with same amount of two solids, measure the initial temperature, and leave for some time. So they have same initial temperature. You can also use for more accurate result, polystyrene cup we can use. That is the first thing. Why we leave it for same initial time so that, or why we leave it for some time? Any mass is acceptable because the technique here is having a mark. The measurement does not, you can mention like 2 gram, 2 gram. You can mention like crush them. That is also fine. Crushing them will increase the rate of this reaction. So first we measure their initial temperature. Then what we did, we take a polystyrene cup because I'm now a reaction we want to take. Now we took a polystyrene cup and we mix the two solid into a or transfer the two solids into a polystyrene cup. Yes, we can record a temperature with a 30-second interval for 3 minutes. That's fine. Or because we want to show it's an endothermic, so temperature should decrease. The second step, what we will do, we will transfer them into the polystyrene cup. Mix them, and we will record the temperature for like 30-second interval for 3 minutes. Or we can also measure the final temperature after like 3 minutes. And then we will compare the temperature if the final temperature decrease. The reaction is endothermic. Because if a final temperature increase, the reaction will be exothermic. That's how. Yeah, we will measure the temperature when the solid are mixed together. But I assume that when I mix them together, they have the same temperature. When I, for example, if this is at 20, this is also at 20. So when I mix them together, the initial temperature will be 20. That's my assumption. That's why I did not mention there that measure the initial temperature again after mixing. I already mentioned like measure the initial temperature when they're separately and leave it for some time so that they have the same initial temperature. Then we mix them together, record the temperature after a certain time interval. If the temperature decrease, it means the reaction is endothermic. Whenever experiment is done, you should always try to make a pattern instead of just leaving the apparatus for 5 minutes or 3 minutes and measure the temperature. It's better you have a like a pattern of your result so you can identify the relation between the quantities. That's why it's not like always measure initial and final, always measure the temperature interval at different time intervals. So you can identify the pattern or the recognize the results easily. How could you show that this contain ammonium ion? So that's a test for ammonium ion. The test for ammonium ion, we add the aqueous sodium hydroxide and it will produce ammonia gas when we warm the mixer. This is a test for the ammonium ion. You have to learn this for paper 6. The test for the gases, the ions will be there. You have to use that table. But for paper 2 and 4, you have to memorize.